Hey y'all, we're doing parallel lines today. I already kind of did a prequel on this. So last class, we talked about what lines and transversals, what those angle relationships are. So an angle relationship could be something like alternate exterior angles. That's a pair of angles that are on opposite sides of the transversal and on the outside of the two lines. So what the fun part is today is that these lines are going to be parallel. And they don't necessarily have to look parallel like I'm doing on here. So what they do is they do this little arrow on two lines that are parallel to show that those two lines are parallel. If I happen to have a different set, kind of like what we do with lines that are congruent, they would do a little stack of two. It kind of looks like a fast forward symbol or a skip. Not a skip, because a skip has a line on the end. But it would be two angles or two little triangles right next to each other, pointing the same direction. So right now we have, let's call it line M, line N, and line T. Remember that I do lower cases for the lines. And I'm going to show you without numbers what is the same as each other. So I'm going to start at this corner. This angle right here is exactly the same as this angle right here. And I know that because they're vertical angles. Okay. Now, I also know that this angle right here is the same as this angle right here. Corresponding angles are congruent on parallel lines. They're in the same spot. And then this one down here is also the same as that. So if this angle was 130, this would be 130, this would be 130, and this would be 130. Okay? Those are all congruent angles. And here's the really fun part. Because of that, the other ones are congruent to themselves. So this angle right here is congruent to this one because they are in 180. And this angle right here is congruent to this one. And because these are the same, all those are the same as each other too. So when I have two parallel lines cut by a transversal, these angles are either the same or supplementary, which means add up to 180. So all the way through, if this was 130, this would be 50, 50, 50, and 50. I'll even write those in. This isn't the case all the time. It'll change. But if this angle is 130 degrees, this one's 130, this one's 130, and this one's 130. And then if that's the case, then this would be 50, 50, 50, and 50. So your real task today is figuring out whether these angles add up to 180 or if they are equal to each other. And I'm going to give you a bunch of examples, or at least some, I don't know. Because that's the whole point there, is what is the same and what equals 180. And I've already kind of given you this hint during class, but that's about half of geometry is figuring out when two things are equal and when two things or multiple things add up to 180. Those are really the two numbers that matter. It's kind of crazy how that works. So let me give you an example. All right, so these are two parallel lines that I know because it's got that little triangle on it. And I can tell that this is angle 4. This is 115 degrees, and that's x plus 5. There's a couple of different ways to do this, which is why they give us angle 4. I could go from 115 to x plus 5, but I don't really know enough about it, right? I can kind of mash it up with here, but I want to use my noggin. So the real question is 115 equal to x plus 5, or is 115 congruent or supplementary to x plus 5? Well, 115 would also be down here, right? Or what they're trying to show us here is that it's also this one. And so what I know is that 115 and x plus 5 are supplementary. So what that tells me in terms of math is that 115 plus x plus 5 equals 180. Again, I don't need the x plus 5 in parentheses, but I kind of don't mind it. So I really get that 120 plus x equals 180. So that tells me that x equals 60 degrees. I'm going to be a good kid. Before I forget, what I want to do is I actually want to go back to our last notes, and I just want to add something very specific. I want to add when lines are parallel, what is the same? And I'm just going to go back to one of these colors because I don't really care. So I'm going to give myself a little code up here, and I'm going to draw 2 parallel lines. So when these lines are parallel, corresponding angles are congruent. All alternate angles are congruent, alternate interior or alternate exterior. And same side whatevers are supplementary. I can't write it all. That means it adds up to 180. To 2. And then we already know that vertical angles are always congruent. So when things are parallel, corresponding angles are congruent, alternate interior and exterior angles are congruent, same side interior and exterior angles are supplementary, and vertical angles are always congruent. So that's a way to maybe remember it at a glance. But I always just like to look at it. And I go, is this obtuse or is this acute? And then I just figure it out. Because this one's obtuse and this one's acute, so they add up to 180 because they're parallel. All right, let's do another example. All right, here's our next example. I have 2 parallel lines. I know they're parallel, even though this one actually isn't technically parallel because I drew it badly because of the little triangle, so we're good. I can use this. By the way, if they're not parallel, I can't use these things. They're just angles. They could be anything. So again, I can use my eyeballs. They have all these postulates and rules and stuff, but look, this one is an acute angle and this one is an obtuse angle. So in this parallel line world, they add up to 180 together. Oh, what was the thing? Was it define the value of x? Sorry. I look at math problems and I just do the math. I don't actually read the directions. Okay, so supplementary. So I'm going to do 136 plus 7x plus 9 equals 180. And so I get 7x plus 145 equals 180. So then 7x equals 35 if I subtract 145. So x equals 5. Oh my goodness, that was not degrees. Ugh, Miss Willard. That's gross. I can't even go back and fix it. All right, and then let me find one more example that's the other way. Ta-da! So now I have 2 parallel lines. I know these ones are parallel. Even though they're going up, I can tell because of the triangles. It's cut by transversal. Now, this is an obtuse angle, and this is an obtuse angle. They're alternate exterior angles, and so they are the same. Angles are congruent. So I know that they equal each other. So I know that 129 equals 6y minus 3, and I'm going to solve that one. So I'm going to add the 3 over here. So I have 132 equals 6y, and then that's like 12 and 12, so that's 11. 22, wow, that's pretty close. I knew that wasn't 11, so y equals 22. And it's not degrees again because I don't know what I was thinking the first time. So once again, half of this assignment is going to be when does it equal 180 and when does it equal themselves? Like when do they equal each other? And so refer back to this. If it's obtuse, they're all the same, and all the acute ones are the same, and then they add up to 180 together. That's how it works. And I just want to reiterate that your book's going to use a lot of words like angle, exterior angle theorem, and stuff like that. That's just saying that these are the same. We don't want to make geometry too hard. I don't think we want to make geometry too hard. Later in this whole thing, we are going to come back to this and actually talk about those postulates and stuff. But for right now, we're going to call it, can you find X? That's all we're going to do. I really hope that helped. Once again, email me, office hours, ask me for help. I'm here for you. But I hope you recognize that I'm listening and I did 3 whole examples today instead of 1. Maybe that'll help you. I don't know. Good luck.